Imagine peering into the vast, uncharted depths of space and glimpsing something that changes everything you thought you knew about the universe. On July 20th, 2025, NASA announced a revelation from the James Webb Space Telescope, JWST, the most advanced observatory ever built that has sent shockwaves through the scientific community and beyond. This colossal instrument, with its iconic gold-plated mirror, has captured what could be the strongest evidence yet of life beyond our solar system, a discovery so profound it redefines our place in the cosmos. By detecting a chemical footprint in the atmosphere of a distant exoplanet coupled with an astonishing array of structured rhythmic light signatures, the JWST has unveiled a cosmic mystery that feels like it was pulled from the pages of science fiction. These findings, located 7 trillion miles away, just over 1 light year from Earth, hint at the possibility of an advanced civilization, complete with what appear to be urban-like lights shimmering in the interstellar void. This is not just a discovery, it's a doorway to a new era of exploration, one that compels us to question what it means to be alive, intelligent, and connected in a universe far grander than we ever imagined. The implications of this discovery are nothing short of revolutionary. When the JWST turned its gaze to a distant region of space, it didn't just see the familiar glow of stars or the faint shimmer of nebulae. Instead, it captured something extraordinary, a clustered array of light signatures pulsing with regularity, arranged in a grid-like pattern and emitting spectroscopic anomalies that defy natural explanation. These weren't random cosmic flares or reflections from icy moons. They flickered in rhythm, held a structured layout, and hovered in gravitationally unlikely locations as if engineered with purpose. Scientists at NASA, after rigorous calibrations and cross-checks, confirmed the data was consistent. What the telescope observed bore an uncanny resemblance to artificial illumination, urban lights perhaps, glowing from a planetary surface or a colossal orbital structure. This isn't a fleeting signal or a vague anomaly, it's a persistent, mathematically precise pattern that challenges everything we thought we knew about the universe. Could this be the first direct observation of technological activity beyond Earth? The possibility alone is enough to keep you glued to this story as we unravel the layers of this cosmic enigma. The JWST's discovery is staggering because it pushes the boundaries of what we believe is possible. Situated just beyond the outer edges of our solar system, in a region once thought to be a silent, lifeless expanse of rogue planets and cosmic debris, these lights shimmer with an eerie familiarity. They mirror the glow of Earth's own urban centers. Think of the yellowish sodium arcs of streetlights, the bluish grids of LED arrays, or the soft scatter of city skylines at night. But these lights, detected in the infrared spectrum where the JWST excels, are on an astronomical scale, suggesting a level of technological sophistication far beyond our own. The patterns are deliberate, alternating between patches of light and dark in a grid-like alignment that evokes roadways, power networks, or even city blocks. Over weeks of observation, these lights fluctuated in a cyclical rhythm, rising and dimming as if following the pulse of a living system. This isn't the chaotic flicker of natural phenomena like auroras or reflective minerals. It's controlled, repeated, and structured in a way that screams intentionality. What makes this discovery so compelling is its defiance of natural explanations. Reflective surfaces like ice or minerals can create luminous anomalies, but they lack the repetition and sequencing seen here. The emissions align with specific infrared wavelengths associated with high-efficiency energy systems, similar to those used in advanced terrestrial technologies. This rules out random cosmic events or solar reflections. Instead, the data points to something engineered, a technological footprint that could be artificial illumination from an advanced civilization. The implications are profound, suggesting a structured urban-like presence in a region of space where none was expected. The light's rhythmic patterns and grid-like arrangement, observed over weeks, indicate a level of complexity and stability not found in natural cosmic phenomena. This is a historic first in observational astronomy, bridging the gap between science fiction and reality. To grasp the significance of this find, we need to understand the JWST's unique capabilities. Operating primarily in the infrared spectrum, the telescope can peer through cosmic dust and gas, revealing hidden galaxies and the chemical makeup of distant worlds. In this case, it detected stable mid-infrared patterns, suggestive of low-energy emissions from a highly efficient source. Unlike intense thermal radiation from stars or planets, these emissions are more akin to the subtle glow of a city at night. Functional, intentional, not wasteful. The source, spanning several hundred kilometers, could originate from a planetary surface, a moon, or even a free-floating megastructure. The spatial cohesion, with hubs of intensity and directional changes, suggests a deliberate design, possibly adapting to a nearby stellar source. The scale of this phenomenon is both humbling and exhilarating. If these are indeed urban lights, they imply a civilization with energy management capabilities far beyond humanity's current reach. The light, visible across a light year, suggests a technological scale that dwarfs our own. The absence of accompanying radio signals adds to the intrigue. These lights don't seem to be communicating. They simply exist, glowing quietly like a distant city unaware of its observers. This raises a tantalizing question. Are we seeing the passive presence of a civilization that doesn't need to shout its existence? Or is this an unintentional byproduct of their daily life? This discovery fundamentally shifts our approach to the search for extraterrestrial intelligence. For decades, initiatives like SETI have focused on detecting radio signals or laser pulses, expecting an active attempt at communication. But the JWST's findings suggest a different approach, looking for the quiet, persistent glow of existence itself. Urban lights, whether on a planet or a megastructure, are a universal byproduct of advanced civilizations. Unlike encrypted signals or fleeting broadcasts, light is hard to hide, especially when used on a massive scale. This could be a game changer for technosignature research, suggesting that structured light patterns may be a more reliable indicator of intelligent life than any deliberate signal. The philosophical implications are equally profound. The Fermi paradox, the apparent contradiction between the high probability of alien civilizations and the lack of evidence, may be less paradoxical now. Perhaps the universe has never been silent, we simply weren't looking in the right way. The JWST's detection of these lights, glowing softly in the infrared, suggests that civilizations may leave their mark not through loud beacons, but through the quiet persistence of their infrastructure. This challenges the assumption that advanced civilizations would actively seek contact. Instead, their existence might be revealed through the incidental glow of their daily lives, a glow that lingers across the vastness of space. The JWST's ability to make such a discovery lies in its unparalleled sensitivity to infrared light, which allows it to detect faint emissions that other telescopes would miss. Positioned at the L2 point, a million miles from Earth, the telescope operates in a cold, stable environment, perfect for capturing the subtle signatures of distant phenomena. Its 6.5-meter mirror, coated in gold for optimal infrared reflection, can resolve details across vast distances, making it ideal for uncovering hidden cosmic secrets. In this case, it detected a source that wasn't emitting intense heat but stable mid-infrared patterns, a hallmark of controlled energy use. This technological marvel has not only expanded our view of the early universe, but also, unexpectedly, brought us closer to answering one of humanity's oldest questions: are we alone? One of the most provocative ideas sparked by this discovery is that these lights may not originate from a planet at all. The source's location in a region devoid of known exoplanetary systems suggests a civilization that doesn't rely on traditional planetary environments. Instead, we might be seeing evidence of a post-planetary society, one that has built artificial habitats or megastructures in the interstellar void. Freed from the constraints of gravity and planetary volatility, such a civilization could achieve unprecedented stability and efficiency. The light's grid-like pattern and cyclical fluctuations hint at a system designed for long-term survival, possibly mobile or self-sustaining, harvesting energy from cosmic sources like radiation or dark matter. This idea challenges the traditional notion of habitable zones tied to stars. A civilization capable of creating its own environment could thrive in the cold, dark regions of space, redefining what it means to be habitable. The energy demands of such a system would be immense, yet the subtle infrared emissions suggest a level of efficiency that surpasses human technology. Could they be manipulating exotic energy sources like zero-point fields or fusion processes independent of starlight? The lights might not be for illumination, but a byproduct of advanced systems. Perhaps heat leakage from perfectly regulated habitats or emissions from synthetic organisms that blend biology and technology. The discovery carries an existential weight that resonates deeply. The light we're seeing is 1 year old, a snapshot of a civilization that may still thrive or have long since vanished. This temporal disconnect underscores the asynchronous nature of cosmic observation. We're not seeing a living civilization, but a moment frozen in time, a silent story told through light. The civilization responsible for these lights, if it exists, has likely mastered energy management on a scale that makes our efforts seem rudimentary. Their choice of location, a seemingly unremarkable region of space, suggests a deliberate preference for isolation, perhaps to avoid the chaos of crowded stellar systems or to harness the stability of the outer dark. This raises profound questions about their intentions. Are these lights a passive signal, an unintentional glow of existence, or are they a deliberate cosmic gesture, an invitation to those advanced enough to notice? The absence of radio noise suggests they're not actively communicating, which could reflect a philosophy of presence over contact. A civilization so advanced might see no need to broadcast. Their existence alone is enough. This idea flips the script on first contact scenarios, suggesting that contact might not be a conversation, but a recognition of shared existence across the void. The discovery carries an existential weight that resonates deeply. The light we're seeing is 1 year old, a snapshot of a civilization that may still thrive or have long since vanished. This temporal disconnect underscores the asynchronous nature of cosmic observation. We're not seeing a living civilization, but a moment frozen in time, a silent story told through light. The civilization responsible for these lights, if it exists, has likely mastered energy management on a scale that makes our efforts seem rudimentary. Their choice of location, a seemingly unremarkable region of space, suggests a deliberate preference for isolation, perhaps to avoid the chaos of crowded stellar systems or to harness the stability of the outer dark. This raises profound questions about their intentions. Are these lights a passive signal, an unintentional glow of existence, or are they a deliberate cosmic gesture, an invitation to those advanced enough to notice? The absence of radio noise suggests they're not actively communicating, which could reflect a philosophy of presence over contact. A civilization so advanced might see no need to broadcast. Their existence alone is enough. This idea flips the script on first contact scenarios, suggesting that contact might not be a conversation, but a recognition of shared existence across the void. Philosophically, this moment redefines our cosmic narrative. Humanity has long imagined itself at the center of the universe, whether through religion, myth, or science. But these distant lights suggest we're part of a larger tapestry, one where others have been shaping the dark for far longer. This doesn't diminish us. It enriches our story, placing us among a constellation of intelligences. The universe is no longer a vast wilderness, but a network of cities, each glowing with purpose, each a testament to the universal impulse to create light. The structured lighting also speaks to a universal truth. Intelligence seeks to impose order on chaos. The grid-like patterns observed by the JWST, with their linear and orthogonal arrangements, mirror the urban layouts of Earth's cities. This suggests that geometry might be a fundamental expression of consciousness, a way to tame entropy with structure. Whether these lights illuminate streets, transit hubs, or cultural monuments, they reflect a deliberate choice to make light, a choice that resonates with our own. This shared impulse, seen across a light year's distance, feels deeply human, even if the source is not. The scale of the phenomenon is both a puzzle and a marvel. Spanning hundreds of kilometers, the light source could be a planetary city, a moon-based habitat, or a free-floating megastructure. Its spatial cohesion and directional changes suggest a dynamic system, possibly adjusting to optimize energy or shield itself from stellar radiation. The lack of a clear planetary association deepens the mystery. Is this a nomadic civilization drifting through space in a self-contained world, or an interstellar factory producing light as a byproduct of cosmic manufacturing? The possibilities are as vast as the universe itself, each one stretching our imagination to its limits. The temporal aspect adds another layer of intrigue. The light's 1 year delay means we're seeing a historical artifact, a moment preserved in photons. This asynchronous connection with a potential civilization underscores the challenge of cosmic communication. Any response we send would arrive a year later, possibly to a civilization that no longer exists. This temporal gap transforms first contact into a study of history, a dialogue with the past that shapes our future. The emotional impact of this discovery is profound. It evokes awe at the possibility of cosmic neighbors, wonder at their technological prowess, and vulnerability at our own exposure. The universe, once thought silent, is now alive with possibility. This reintroduces mystery into a scientific landscape that often seeks certainty, reminding us that the unknown is not a void, but a partially lit room waiting for us to explore. Ethically, the discovery raises critical questions. Should we attempt contact or respect the apparent solitude of this civilization. If they are vastly more advanced, our signals might be ignored or misinterpreted. Caution becomes a form of respect, a recognition of their autonomy. The decision to engage or not requires a humility that acknowledges our youth as a species. We are not the first to light the dark, and we may not be the brightest. The JWST's discovery is a catalyst for new scientific frontiers. Future telescopes will likely prioritize infrared sensitivity, designed to detect the subtle glow of artificial light. Algorithms will evolve to identify patterns of structured illumination, distinguishing them from natural phenomena. Missions may shift from searching for habitable worlds to exploring interstellar voids for signs of engineered habitats. The concept of light pollution could become a key indicator of life, transforming how we approach the search for intelligence. This moment also invites us to reflect on our own cosmic presence. Our city lights, radiating outward since the 19th century, have made Earth a visible beacon. If we can see light 7 trillion miles away, others may have seen ours. This possibility that we are already part of a cosmic network challenges our sense of isolation. We are not alone in shaping the darkness, and the universe may be a constellation of glowing civilizations, each telling its story through light. The lights detected by the JWST are more than a scientific anomaly. They are an invitation to rethink our place in the universe. They suggest that civilizations may not seek contact but simply exist. Their glow a passive signal of presence. This redefines first contact as a moment of recognition, not communication. The universe, once thought silent, may be whispering with light, waiting for us to develop the eyes to see it. As we build sharper instruments and send probes farther, we may find that such lights are not rare but common. A network of cosmic cities, each glowing with purpose. The JWST has lifted a veil, revealing a universe where warmth and light persist, not as accidents, but as acts of will. These lights 7 trillion miles away are a reminder that the search for life is no longer about whether it exists, but about how often it chooses to be seen. The questions now are endless. How do these civilizations live? What do they fear or value? What does it mean to build a home in the vastness of space? And what does it mean to be seen across a void so immense that even light takes a year to cross it? The JWST's discovery compels us to rethink the methodologies of the search for extraterrestrial intelligence. SETI. Traditional approaches have leaned heavily on detecting deliberate signals, radio waves, laser pulses, or even modulated light patterns designed to attract attention. Yet, the lights observed 7 trillion miles away suggest a paradigm shift. The most reliable signatures of advanced civilizations might not be intentional broadcasts, but the incidental byproducts of their existence. Urban lights, whether illuminating cities, habitats, or megastructures, are a natural consequence of technological societies. They persist, they endure, and they are difficult to conceal, unlike encrypted signals that can be cloaked or transient pulses that fade quickly. This realization could redirect SETI efforts toward mapping the infrared sky for similar patterns, creating a new field of cosmic urbanology that seeks to identify the glow of infrastructure across the galaxy. The JWST's data, with its grid-like patterns and cyclical fluctuations, offers a blueprint for what to look for: structured, repetitive, and mathematically precise light emissions that stand out against the randomness of natural phenomena. Beyond the scientific and technological implications, the discovery invites speculation about the cultural and aesthetic sensibilities of the civilization behind these lights. On Earth, urban lighting serves more than functional purposes. It reflects our values, our priorities, and even our art. Cities like Tokyo or New York glow not just to guide, but to inspire, with skylines that tell stories of ambition and creativity. The grid-like patterns observed by the JWST, with their linear and orthogonal arrangements, suggest a civilization that values order and symmetry. But could there be more? Might these lights be arranged to reflect an aesthetic principle, a cultural narrative, or even a form of cosmic art? The cyclical fluctuations could indicate daily routines, but they might also represent rituals, festivals, or cycles of remembrance that carry meaning beyond mere utility. The idea that an alien civilization might illuminate its world not just for function, but for beauty resonates deeply, suggesting a universal impulse to create meaning through light. This possibility transforms the discovery into more than a scientific milestone. It becomes a glimpse into the soul of another intelligence, one that, like us, seeks to shape the dark in ways that transcend survival. The JWST's findings also have immediate implications for human technology. If these lights represent a civilization with energy systems capable of emitting detectable signals across a light year, they hint at engineering feats that could inspire our own advancements. The subtle infrared emissions suggest an efficiency that surpasses our current capabilities, possibly involving technologies like quantum energy systems, zero-point energy, or advanced fusion that minimizes heat loss. Studying these emissions could guide humanity toward developing more sustainable energy solutions, particularly for space exploration. If a civilization can thrive in the interstellar void, far from stellar resources, it implies self-contained systems that recycle air, water, and nutrients with near-perfect efficiency. Such technologies could revolutionize human space habitats, enabling long-term missions to Mars, the outer solar system, or beyond. The discovery also underscores the importance of infrared astronomy, likely spurring investment in next-generation telescopes designed to detect similar technosignatures. This could lead to a new era of space exploration, where the focus shifts from planetary colonization to building resilient mobile habitats that can sustain life in the deep cosmos. What if the lights detected by the JWST are not an isolated phenomenon, but part of a larger cosmic network? The structured patterns and their location in a seemingly unremarkable region of space raise the possibility that we've glimpsed a single node in a vast interstellar infrastructure. Advanced civilizations might construct distributed systems, networks of habitats, observatories, or energy stations positioned at strategic gravitational points to leverage cosmic phenomena like gravitational lensing or energy harvesting. The grid-like arrangement could be one element of a galactic web, with nodes exchanging data, resources, or even populations across vast distances. This hypothesis transforms our understanding of the universe from a collection of isolated systems to an interconnected tapestry, where civilizations cooperate or coexist in a shared cosmic ecosystem. The absence of radio signals might indicate that such networks use light-based communication, encoded in the patterns of their illumination, or rely on entirely novel methods beyond our current understanding. The JWST's discovery could be the first clue to this network's existence, urging us to search for similar signatures across the galaxy and reframe our place as potential participants in a cosmic community. The temporal aspect of this discovery adds a layer of complexity that challenges our understanding of evolution and longevity. The light we observe is a year old, a mere snapshot in cosmic terms, yet it implies a civilization that has endured long enough to develop infrastructure on an astronomical scale. On Earth, human cities have existed for mere millennia, yet these lights suggest a society that may have persisted for tens of thousands, if not millions of years. Such longevity requires not just technological prowess, but governance, cultural stability, and resilience against existential threats. The cyclical nature of the lights might reflect not just daily routines, but evolutionary cycles. Perhaps shifts in energy use that correspond to societal phases, environmental adaptations, or even biological transformations. If this civilization is post-biological, composed of synthetic or digital intelligences, it could operate on timescales that dwarf our own, with light patterns that reflect eons of activity rather than days or weeks. This perspective forces us to confront the possibility that intelligence evolves toward forms we can scarcely imagine, where the boundaries between biology, technology, and consciousness blur into something entirely new. This discovery is not just a moment of awe, but a call to action. It demands that humanity invest in the tools, minds, and imagination needed to explore this new frontier. The JWST has shown that our technology can detect the subtle glow of potential civilizations, but we need more. Telescopes with greater resolution, algorithms that can parse complex light patterns, and probes capable of venturing into the interstellar void. This could spark a global renaissance in space exploration, uniting nations in a shared quest to understand our cosmic neighbors. It also challenges us to reflect on our own visibility. Our city lights have been broadcasting our presence for over a century, a cosmic signal that may have already been noticed. This realization should inspire us to be better stewards of our planet, to create a world whose glow reflects not just survival, but wisdom, creativity, and hope. The lights 7 trillion miles away are a mirror, showing us not just what we might find, but what we might become. A civilization that lights the dark with purpose, purpose, ready to join the constellation of stories that illuminate the universe. This discovery is not a conclusion, but a beginning. It's a call to explore, to imagine, and to prepare for a universe that is not empty, but alive with light. The James Webb Space Telescope has shown us that even in the coldest corners of existence, someone, somewhere, turned on the lights. And that single flicker has changed everything.